Good morning.
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 Okay, so today we're going to be talking about our last section of the semester, section 7.4. So we're going to be spending some time on 7.4. We have an exam and then review for the final. So on your sheet that you got today, once again, the probability of an event is the number of ways that it can happen over the total number of ways. So we're going to revert back to our counting that we did before. So let's remind ourselves, in our first example, we're looking at an unbiased, better known as a fair coin, is tossed 5 times. So in our first example, we're looking at coin being tossed 5 times. So the first thing we're always going to be looking at is what is the total number of ways that that experiment or outcomes that that experiment has. So when we look at tossing a coin, we're looking at 5 times. Each of those can be filled by 2. So toss the first time and the second time and the third time and the fourth time and the 5th time. What does that give us as the total number of ways that this experiment can turn out? Ethan.
It is, give me 1 second. Is it 32?
It is 32. So in each of these problems, the first thing we're looking to do is to find what's going to be in the denominator. So 32 is going to be in the denominator of each of these probabilities. So what is the probability that the coin will land tails exactly 3 times? So does order matter in this problem? Christina, does order matter when I'm talking about getting
Yes.
3 heads? Well,
Exactly,
yes.
yes.
Yes and no. It's sort of that in between. We are going to use combinations for this. There are 2 ways to treat this. We can treat it as this is a 5-letter word. And so we could say that we have 5 factorial over, we're going to have 3 heads and 2 tails. But notice when we only have 2 choices, that's the exact same thing as saying that we have 5 objects and we're going to choose 3 of them. Now remember, we're counting up total number of ways that that can occur. And so now let's go ahead and do that calculation with our calculator. So, Denon, what did you come up with if we do combinations of 5 objects taken 3 at a time?
Give me 1 second. I gotta find the equation.
Okay. So remember, on your calculator, it's under probability, which is under math.
For some reason, when I do math and go to probability, I have it'd be the NCR, correct?
Yes.
When I click it, it says answer and then NCR.
Which calculator do you
I have
have?
a TI 84 plus.
Okay, with a TI 84 plus, I have the silver edition. Does it?
Can I help him?
Sure.
I think, are you putting in the 5 before you put in the math CR?
Do I need it? So I know I'm not.
Yeah, so put the 5 in first, then go to math, the CNR, and then put 3.
And then put
Or
3.
click enter, and then put 3.
Okay. So
'Cause
5.
I got stuck on that too.
Thank you,
Okay.
E.
No
Thank
problem.
you.
Yeah,
I
you
got
got it.
10.
What'd you come up with, Denon?
10.
Okay. All right. So for part A, we're looking at 10 over 32. Now, let's go back to, we were kind of debating whether this is correct. So if we do the calculation of all of our possibilities, they should add up to 32. So we could have 5 and choose no heads. Let's go ahead and do that and find out what the answer is for that. What do we come up with? Let's see.
Oh,
Jordan?
I got 1.
Okay. Then we could have 5, choose 1. And Zach, what did you come up with for that?
5.
Then we have 5, choose 2. Jim, what are you coming up with 5, choose 2?
10.
And we know 5, choose 3 is also 10. We have 5, choose 4. Jake, what about 5, choose 4?
I got 5 for that.
Okay. And 5, choose 5. Delaney, what about 5, choose 5?
I got 1.
Okay. So here are all our possible outcomes. Go ahead and add those all up. Hannah, when we add all these numbers up, what do we get?
I got 32.
Exactly, which is, so in other words, each of these represent an event, And when we add up those, we get the 32 outcomes that we talked about. So this is no tails, one tail, two tails, three tails, four tails, five tails. So that's all the ways that that particular experiment can occur. When we add up all of the number of outcomes in each of those events, we come up with the total sample number of outcomes in our sample space. Christina, does this make a little bit more sense now? Do you see why we're using combinations? Because when we use those and we add up, we get our total sample space.
Yeah.
Okay. All right. So our next question is at most 3 times. So we have to do our interpretation of at most 3 times. So at most 3 times means that it could be 3. Or, Stephen, what else could it be?
2 or 1.
Could be 1. Let's go in order. You said 2 as well, didn't you?
Yeah.
Or 1 time, or 0 times. So it could be any of those 4 when we say at most 3. Question on that before we go on. Marcus, does this make sense to you?
Yes, it does.
Okay, so notice now what we're going to do is we're going to look at 3 times. That's 5, choose 3. So that gives us 10 over 32. Plus 2 times gives us another 10 over 32. Plus 1 time gives us 5 over 32. Plus 0 times gives us 1 over 32. So what do we wind up with for our answer?
.8125.
Okay. And this was 26 over 32? Yes?
Yes.
Yeah.
Okay. Does that make sense to everybody? Question on that. Okay. So our next was on that we had tails on the first and last toss, and we don't care what's in between. So for that particular problem, we're looking at the probability of it starts with tail and ends. With tail. Now, this is a little bit different than what we had over here, because over here we just said we wanted 3 tails and we didn't care where they were. Here, what we're going to do is go back to our counting like we did in the first section, where we had, if we look at these 5 spots that we have to fill, there's only one way to fill that first spot, and there is only one way to fill that second spot. And so what about these in-between spots? Did we specify if it had to be a head or a tail in any of those other spots?
No.
No. Okay. So that means that I can put 2 in each of those. So that means how many ways can we start with a tail and end with a tail? There's 8 ways that we can do that. So we have 8 out of our 32. And so what does that give us? As a decimal?
0.25.
0.25. Everybody good with that now? Okay. So example 2 is 2 cards are selected at random. From a standard deck. So once again, what we're going to look at is finding the denominator. Okay, so we have how many ways to choose 2 cards. So go ahead and perform that calculation, and then we're going to do a comparison. So Kayla, what did you use to find out how many ways to choose 2 cards?
I wasn't really sure how to do this one.
Okay, so this is like when we were doing poker hands. So if I get an ace of hearts and then a 10 of clubs, or a 10 of clubs and an ace of hearts, that doesn't matter. So we're going to use combinations to choose those. Does that make sense, Kayla?
Yeah, it does.
So we have 52 cards and we're going to choose 2 of them. So Kayla, do you have your calculator handy to do that?
Yes, I got 1,326.
I'm sorry.
1,326.
Everybody good with 1,326? Any questions on that? Okay. So let's look at, so that's going to be the denominator for each of the probabilities that they're asking us about. So Part A asks us for a pair is drawn. So we have our 1,326. Now we did a pair back when we did poker hands. So the first thing we have to choose, Ashley, is what when we did that?
I'm sorry, can you say that again?
So back when we were doing poker hands, we talked about choosing a pair.
Mhm.
When we chose a pair, what was the first thing that we chose? Do you remember?
Mm-mm.
How about rank? So we chose the rank. How many ranks are there in our deck?
4.
Those are suits.
Okay.
How many ranks?
13.
13. Okay. So out of those 13, we're choosing 1. Everybody good with that? And then what's happening? Out of the 4 in that rank, we're choosing 2. Okay, so what does that give us in the numerator? Matt, did you calculate? 13 choose 1 and 4 choose 2 and do the product?
I'm typing it in right now. Hold on.
Not yet?
Yeah, not yet. I got 1/17. Is that? I think I
Your,
did it wrong. Calculator.
okay. Did everybody get that?
Yes.
Yes.
What did you wind up with, Ashley?
As a decimal, 0.0588.
I just wanted to know what you had in the numerator, first off.
78.
78. Okay. Just so everybody sees what number before we go to the decimal. Now, Ashley, what did you wind up with your decimal?
0.0588.
Okay. Now be careful on the homework to make sure that when you're doing it, you read carefully how many decimal places they want. And Stephen, did you have to put that extra 0 in on that one problem that you asked me about? Was that what was going on?
If the 0 was at the end, I didn't have to.
Okay. And so you do have to be careful to pay attention if there is rounding going on, because it will, if you have that wrong, last decimal place wrong, it will say the answer is wrong. So be careful. Okay. Does everybody agree with that? Any question on that? Okay, 2 black cards are drawn. So we know that we have the 1,326 in the denominator. We're looking for in the numerator, E. How many cards can we draw from that are black in our deck?
Isn't it 26?
It's 26. And we're going to draw 2. Does that make sense to everybody?
Yeah.
Okay. All right. So let's see what happens there. First, I want the number.
I got 325.
325. Thank you, Stefan.
You're welcome.
So we now have 325 over 1,326. So what decimal am I looking at? Let's see. Jim,
0.2451.
question on that. Okay, so let's look at the next example.
Wait, so the denominator, the 1,326, that's just the pairs, right?
That's the total it's the total number of 2 cards that we can choose. So in other words, the way that we got the 1,326 is we took 52 cards and we chose 2 of those.
Oh, okay, okay.
Matt, did that answer your question?
Yeah.
All right. So our next example is 4 marbles are selected at random without replacement from an urn containing 3 red marbles and 5 green marbles. Find the probability of the given event. So first of all, we have to, in example 3, find out what the denominator is. So we're choose, how many marbles are we choosing?
4.
We're choosing 4. Out of how many?
8.
8. Okay. So our denominator is going to be We have 8 objects and we're going to choose 4. So let's go ahead and do that calculation. Christina, what did you come up with for 8, choose 4?
$70.
Okay. So 70 is going to be in the denominator of each of our probabilities. Question on that before we go on. Okay, so 2 of the marbles are red and 2 are green. So let's think about that. Okay, so this was one that, similar to, remember when you were choosing from seniors and juniors? Back in your counting, you were making up a group, and you were going to choose so many seniors and so many juniors. And what you had to do then was multiply those, because you were going to find out how many seniors you chose and how many juniors. So we're going to look at how many ways the event of choosing 2 red and 2 green can occur. So let me write down on this other board that we have a total of 3 red marbles. And I'll use R for red, and 5 green marbles. So I want the probability of 2 red and 2 green. So we know 70 is in the denominator. Now we have to calculate how many of those 70 contain 2 red and 2 green. Well, if I want 2 red, that means out of the 3 red, I have to choose 2. And out of the 5 green, I have to choose 2. Let's go ahead and calculate that product of choosing from 3 objects 2, and then from 5 objects 2, and then multiplying them together.
Got 30.
Did everybody come up with 30?
Yes.
Okay, let's go 4 decimal places, Denon.
4286.
Question on that. Okay. Part B says 2 or 3 of the marbles are green. So or means that we have the probability of 2 red, 2 green, or, well, if I have 3 green, how many red am I gonna have, Delaney? If I have 3 green and I'm choosing 4, how many red do I have?
Just one.
So 1 red and 3 green. Now, what does or mean as far as our probabilities? What are we going to do with our probabilities if we have an or? Jim?
We're gonna add them.
Okay. So we've already calculated the 2 red, 2 green is 30 over 70. Plus, now I have to calculate the probability of 1 red and 3 green. So that means that out of the 3 reds, we're going to choose 1. And out of the 5 greens, we're going to choose 3. So Jake, what did you come up with for the numerator of the second fraction?
And when I added those two numbers together, it was 13.
You wound up with how many?
13?
13? Did anybody else come up with 13? Anybody else want to share their answer?
I got 30 again.
Yeah, 30 over 70.
30 over 70. Jake, you want to try that again and make sure you have the multiplication sign in the right place.
I thought you guys were adding them. My bad.
Okay. All right. So are we all good now with that? So that gives us a total of 60 over 70, which for a 4-place decimal, what are we looking at?
I got 0.8571.
0.8571. Okay. Question on that. Does that make sense to everyone? Okay. So let's look at example 4. Or maybe this would be a good place to end. And we'll start with example 4 on Friday. So one of the things you should be thinking about when you're doing these is if you're not sure you're doing them correctly, add up all the possibilities and see if you come up with the total number in your sample space. So for example, if we look, let's just go that route here. So I could have no reds and four greens. We already have one red and 3 greens is 30. We have 2 reds, and 2 greens. And that's 30. And then we have 3 reds and 1 green. Okay, let's go ahead and calculate those other 2. Hannah, did you come up with something for choose 3, choose 0 times choose 5 out of 5, choose 4?
I got 5.
Okay. And Zach, what about the last one? What did you come up with for that?
5.
Notice if we add these all together, what do we have?
70.
70,
70.
which was the total number
The total,
in
yeah.
our sample space. So if you're wondering if you're doing it right, just go ahead and break it down into the way you're thinking about it, add those up, and that should agree with the number of outcomes in your sample space. Does that make sense to everyone?
Mm-hmm.
Question on that? Okay, tomorrow after, we don't have class officially tomorrow, so during this time tomorrow are office hours. So if you have questions on homework problems, we'll look at those tomorrow during this time. Okay, questions? All right, I'll see you on Friday for sure, and if you have questions, you can Zoom in tomorrow during this time. Okay, have a nice day, have a great evening, and I'll see you on Friday.
When's the exam? I missed the first part where you
The
talked about
exam
that.
is going to be next Wednesday.
Next Wednesday. Okay. And did you get me for a roll?
Yes, I did.
Okay, awesome.
Okay, have a
you.
nice evening.
Thank
Bye
you.
now.
Thank you, buddy.